What's up, YouTube? So I decided to start covering start a new video series about Dmvpn, its application, and try to bring you some real case scenario. When would you use it, and how would you deploy it, and its variations also. Um, as you might know, Dmvpn is a tunneling solution that allows to connect different branches of a company or different companies over a public internet, over the internet. So we'll be using this topology that I have right here. We won't look at the configuration inside the internet service provider because that's not our goal. Our goal is how to allow the communication between those sites in New York, London, Dublin, Brussels over a public internet. And I'm just using the address there for reference, but we won't look at it because, as I said, I want it to be like a real use case where a company has different branches, and what they want is to interconnect those branches with their local networks, but using an internet service provider. So we normally, when we're deploying this solution, we are unaware of what the service provider has. We don't care, but we want is to build an overlay, means a tunnel above the existing network. So the service provider infrastructure will be considered as an underlay, and we're going to build a tunnel that is going to be an overlay. As we don't know and we don't care the infrastructure underneath or at the service provider, so will the service provider be unaware of our tunnel. Okay, and I'm referring as tunnel is going to be a VPN tunnel, but doesn't mean that we're going to secure this tunnel. And this is some misconceptions that I often read also about Dmvpn. Dmvpn is a tunneling solution, and we can secure what is being sent inside this tunnel. Okay, but we're going to see this further. And to start off, I've already configured all the sites. They have reachability to each other. So we can start with site New York, and you can see that I have somewheres access to internet. I'm able to reach 8888. Basically, all the sites have reachability to internet, and it's expected every site is able to reach the other site. Okay, if I try to reach Dublin from London City in 192.16.0, and that should be 10, so it is successful. But as we know, we can't advertise our local network because that's our local network across the internet. Okay, we don't want this to be exposed. So to do that, we're going to use Dmvpn, and we're going to start with Dmvpn Phase One. Dmvpn has different three types. Basically, we have Dmvpn Phase One, Dmvpn Phase Two, and Dmvpn Phase 3. Okay, and we're going to start with Dmvpn Phase 1 using what is called static mapping. And how does it work? So let's start with configuration. Okay, so for this scenario, there are some terminologies that are used in Dmvpn. We have a hub, that's a central point of our overlay. And we have spokes, and spokes, they are clients, they are um, endpoints that require information update, or let's say control plane from the hub. So we have hub and we have spokes. Okay, and the hub will be the central point, and spokes will be our different branches. And we can have one hub, we can have multiple hubs for redundancy, and we can have multiple spokes. So let's start configuring our hub. So first we have to configure a tunnel interface, and we're going to assign an IP address. As you can see, I'm using the 10.1.1 something across all branches. So for this tunnel interface, we have to assign an IP address as well. I'm just going to use 10.1.5. So my hub is going to be 10.1.5.1. It's going to be /24. And then I have to specify where this traffic is going to be sourced from, and I can reference my interface, and this interface has to be my interface towards the ISP. It means my NBMA, non-broadcast multimedia access interface. And I have to specify that this tunnel mode is going to be a GRE. As you know, GRE allows for point-to-point tunnels. So this one, we have to choose multi-point. So it means that we want a GRE tunnel, but that allows us to have multiple tunnels. Okay, so it's going to be tunnel mode, GRE, multi-point. And that should be enough to have the tunnel operational. Now we need a second part of this configuration, and this is going to be the Nhrp protocol. And Nhrp protocol is the one that will allow us to act like ARP fashion. It will allow to resolve the public IP address with the tunnel IP address. Okay, so let's first enable Nhrp on the interface. And now we have to statically map every spokes we have in our network. So let's say that London, its tunnel IP address is going to be 10.1.5.2. And I know this IP address, it will be breachable via its public IP address 192.16.0, I believe it's 6. Okay, and we have to do the same thing for all the other sites. So let's say that Dublin will have IP.3 and its public IP address it's 10. As for Brussels, it's going to be 4 and its public IP address it's 14. Okay, and that should be enough to bring our tunnel up. So let me copy and paste this to New York, multi-configuration, and paste it. Okay, and should see the tunnel coming up, and we can look at the interface status, and we can see it's up, which means that I should be able to ping myself. Okay, now for spokes, the configuration is a bit different. So let's start first with London. London, and London tunnel IP address is 10.1.5.2. Here at the source, we can specify the interface or the IP address. So just for demonstration, I'm going to change to my public IP address, and London should be 6. Now the tunnel mode as we're talking, as I said earlier, this is phase one static. So this has to be a normal GRE tunnel. So here we have to specify the destination, and the destination is going to be the hub public IP address. And we have to statically map all the other spokes on the network. So here should be 1 and 2 and the other one as well. Okay, so let me copy these, tunnel source, tunnel destination, and paste this on London. And I should see my tunnel up. Okay, let's check the interface. It's up. Can I ping myself 10.152? And can I ping the hub? So before that, I just want to show you some verifications commands that you can use, are very helpful. I can see here the mapping, the Dmvpn mapping table, and here we see the NBMA IP address and the tunnel IP address, and that London should be able to reach normally. Okay, so scenario is the same for all the other spokes. I'm just copying past these twice and change here. So next one should be doubling. Doubling is third, too fast, too slow. And I'll just change here to be the interface because it's speeds the process. So here I have to change to 2, and this guy should be 6. Doubling, let me copy here and paste. Now Brussels, and it should be 4. And my tunnel source is 0, and let me change here 2 and 6. Okay, so I see tunnel, it's up. Now can I ping 5.1? I can. 2, I can. 3. So every tunnel, every spoke is able to reach every other spoke. And now let's take advantage of this tunnel. Is that we want our local networks to be advertised. Okay, that's the main purpose. So for this demonstration, let's start by using EIGRP. Okay, I'll just say EIGRP net1, and I'll enable this using 10.150. And this is enabling EIGRP at the tunnel interface, and I'm going to advertise my local interface. Okay, and just to make things faster, I'm just going to use my node here because it's faster to change. So it's going to be 10.150. This is wildcard mask, and 10.120. 255, and that should be London. Boom, and it's done. And let's check something. Do show IPsec interface. Typo. Do show IPsec interface. There we see it's enabled at the tunnel and my local interface. Now, do we have any neighbors? No, but it's enabled. Let's look at the hub. Do show. Oh, I see adjacency, it's up. So do show IP EIGRP interface. See, there is one peer. Everything should be okay. So do show IP EIGRP neighbor, and I see one neighbor, but the queue count is increased and round trip time is also high. And if I look at my routing table, it's empty. Well, actually I did all this just to show you that by default, multicast is not enabled on GRE tunnels. So we have to enable that, and we see that now it's going to go over this process of retrying, but it won't work. So to solve this, what we have to do, actually, let me add this. We have to tell the tunnel to support multicast, and multicast for every spoke. So in this case, 192.16, yes, 1606. Let me pass these 6 and 10 and 14. So okay, that's part of the solution. Spokes, they should do. You will notice that I'm using a lot of shortcuts when typing these commands to just make it faster to type. So 192 is going to be 192.16.02, and I have to do this for everyone as well. And it's going to be the other one is 10 and the other one is 14. Okay, so London, done. Let's see if something different shows up. Sometimes what you want to do is to flap the tunnel. Okay, but let's just check something first. Oh, and we can see that. And I've received the LAN network from New York. So instead of testing from the spoke itself, I'm going to call one of the clients, and it should be 192.168.2.3.4.136. 32.781. 32.781. Okay, and just to show you that every spoke has the second IP address in this network. Now from London, I'm using 10.1.2 and my IP is 10.1.2.2. I should be able to access the internet, and I should be able to access 10.1.2.2 as well. And we can see this, that we're taking a different path. If I try to reach 888, you can see that this is my gateway, this is its public IP address, and this is at the service provider, and that goes on. Okay, now if I try to reach 10.1.1.2, it's taking a different path. It reaches my gateway, then it is sent inside the tunnel 10.1.2.2. Okay, so the behavior is going to be the same for all the other spokes, but there is one more thing that I need to change and I need to share with you, and just give me a second while I'm changing this. So here is going to be 6 and this goes to doubling, right? And paste that, and here should be 8. No, here should be 10, and this goes to Brussels. Okay, now let's see. I have to enable EHIP 3, and that should be doubling. and for on process. Okay, now if I look at the hub to show IP EIGRP enable, I have all spokes up and I'm receiving all their LAN interface. So if I check here at London, I only see one network, and this is the one from the hub. And the reason why is that this is not related with Dmvpn itself. This is EIGRP behavior. Is that EIGRP won't advertise a network back from the interface to receive the advertisement. That's what it's called split horizon rule. So to solve that, we have to change this on hub itself. So by using no IP split horizon and EIGRP 1, it's going to flap the tunnel and to bring the agencies back. And now when I look at my routing table, every spoke will have each other's network. So okay, check on doubling as well, and everything looks nice. Let's show IP IPsec done. Okay, so we have deployed Dmvpn using static mapping, and we're running a dynamic routing protocol, EIGRP. We could be using OSPF, and I'm going to show you guys in the next one what it's like using OSPF with Dmvpn. But there is something that I want to highlight as well, is that as you can see, this can be a very tedious configuration. Oh, this one. Like for every spoke we add in this network, we would have to update on the hub, and we would have to update as well on everyone's spoke. And it's hard to scale. That doesn't scale well. Okay. So in the next video, I'm going to show you guys how to use dynamic mapping. And dynamic mapping allows us to have the same result we have right now, but with the advantage that it's scalable, or scalable than using static mapping. Okay, so I'll see you guys in the next one. Thank you.